Good morning, it's 3:40. It's 8:32 a.m. Friday, December 2nd. I'm Paul Fico coming to you live from the Weisenmaker Engineering Building. Joining me today is my associate Juan Vargas Gomez, who is out now interviewing the populace on the topic of AC versus DC. Later, we'll get the opportunity to film experts on the topic, namely Somil Gupta and Dr. Nathan Summers. Heading now to Juan Vargas.
Howdy, we're here with
Josh,
majoring.
computer science.
What do you know about DC and AC?
Got no clue.
What do you know about the applications?
Has something to do with electronics.
Thank you.
Monish,
Majoring.
computer engineering.
What is the benefit of DC versus AC?
I'm not sure, but isn't there a band called AC/DC?
That is correct. Thank you. Howdy, we're here with
Rohan.
Rohan is going to tell us about what he knows about DC and AC. What do you know about AC and DC?
Well, I know DC is direct current, and AC is alternating current, and DC would just be like a straight like voltage, whereas like AC would be like given like a phasor or like maybe like a sine, like a sinusoidal kind of thing. So you can model it. Actually, you model it with phasor. It's like a signal.
Thank you, Rohan. Howdy, everybody. We are here today with our special guest, professional engineer, Dr. Nathan Summer, who is going to talk about the history of DC and AC. Please tell us a little bit and the audience about the history of DC.
DC, or direct current, was produced in 1800 by an Italian physicist, Alessandro Volta. The nature of how current flowed was not yet understood. French physicist André Marie Ampère conjectured that current traveled in one direction from positive to negative. In the late 1870s and early 1880s, people saw electricity starting to be generated at power stations. These were initially set up to power arc lighting, running on very high voltage, using direct current or alternating current. This was followed by the widespread use of low voltage direct current for indoor electric lighting in business and homes after the inventor Thomas Edison launched his incandescent bulb based on electric utility in 1882. Edison developed current during these early years of electricity. Direct current, or DC, was standardized in the US.
Please tell us about the history of AC now.
The first alternator to produce alternating current was a dynamo electric generator based on Michael Faraday's principles, constructed by the French instrument maker Hippolyte Pixii in 1832. Pixii later added a commutator to his device to reduce the more commonly used direct current. In the US, William Stanley Jr. designed one of the first practical devices to transfer AC power to efficiently between isolated circuits. Using pair of coils wound on a common iron core, his design, called the induction coil, was an early transformer. In 1888, alternating current systems gained further viability with introduction of a functional AC motor, something these systems had lacked up until then.
Thank you so much. We are here now with Somil Gupta. Thank you for joining us. He is an aspiring graduate student, and he's going to talk to us a little bit more about AC and DC. What is AC and DC?
See, AC is a form of electricity where the flow of charged particles, electrons in this case, are basically periodically changing and reversing their direction. DC, on the other hand, is a form of electricity where the current or electrons, the current is produced by the flow of electrons, only moves in one direction.
That's very interesting. Thank you. What is AC used for?
AC, or alternating current, is generally used for long-distance transmission of power.
Okay. I wonder why.
Well, you see, when we're trying to transmit power, the goal is to reduce the amount of power losses during transmission. So therefore, power must be transmitted at a high voltage. This is because when electricity is sent through a wire, the heat generated is equal to the square of the current, and that heat generated is the power lost. So compared to a direct current, alternating current voltages can be more efficiently and more easily stepped up and down using transformers, making it more suitable for power supply. This has to do with transformers only working with AC mutual inductance due to their reliance on changing magnetic fields. Additionally, due to the way generators turn and create energy, it's easier to work with AC than DC. And this is why you see AC coming out of most power outlets in just about every single building you enter.
Now, what about DC?
See, with DC, you'll see that in just about every single device that involves a battery. It involves storing power in batteries for future use.
So you're saying the phone I'm holding right now uses DC?
That, your laptops, flashlights, CCTV cameras, just anything that, like I said, involves batteries. And now, this is benefited by the fact that DC's power is also more consistent in terms of voltage delivery. So, for example, when the direction of the current is constantly changing, and you have a capacitor or an inductor inside the current, there's a delay or advance in the current flowing to the load. But since DC current is always producing a constant current, there is no delay or advance inside the current delivered to the load. And similar to batteries, solar panels do the same thing. Solar panels create a direct current when the sun shines on the panels and stimulates the flow of electrons.
So do all electronic devices use DC?
No. Actually, no. So your refrigerators, your lamps, washing machines, these things still use AC power. And they have other things that allow them to convert and benefits for this.
Thank you very much, Somil. We appreciate your time.
Of course.